So, um, just a quick recap. If you notice the double parentheses here, the first set of parentheses is for the function, saying here's a function, and what's inside these parentheses will be the argument for that function. And so the argument then is this tuple, which is in this case 3, 3, which means three rows and 3 columns. If you just had a single integer, if you wanted a one-dimensional array, you could just provide a single integer instead of a tuple. So up next is indexing, and indexing is very similar to what we've seen with various other data structures in Python or other data types. So we have, just like we have with lists and with strings, we have some of the same functionality. So v was a vector, if we recall, so if we want to just get the first element of that, it would be index 0. So we just use bracket notation like usual. Since M is a matrix, we can provide a two-dimensional index. We can say row 1, column 1, and it will give us that value. And since it's a two-dimensional array, if we want a whole row, we can just provide a single coordinate. So this is row 1, column 1. If we just provide a single index, it'll just give us the whole row. And we can get the same thing. If we want to be more explicit, we can use this colon to say we want row 1 and then all columns. So that will work that way. And we can also say we want all rows and just column 1. So it'll give us 2 and 4. And we can use the same notation to assign new values using indexing. So we can say to position 0, 0, we want to assign that -1. In fact, we did that above in the example. But now we're changing that. So now that first entry, position 0, 0, is a -1. Similarly, we can assign an integer to a whole row or column. In this case, we're going to say row 0, all columns will be 0, and then all rows, column 1, will be -2. So if we look at that, first we changed row 0 to 0, but then we changed column 1 to -2, so we have a 0 here, a -2 here, and then that 3 is still there. So it's all very similar to what we've seen, but now we have the ability to do multiple dimensions. So slicing is, again, similar to what we've seen, so let's make a new array that's just one-dimensional from 1 through 5. And if we want from position 1 to 3, we would use this notation with a colon. So here the colon is specifying a range and not saying I want all rows or all columns. And so this gives us position 1, 2, but not including 3. So that sub array is another array that just is 2 and 3. And these slices are mutable. So like lists, but unlike tuples, we can change an array as long as the data type is consistent with its existing data type. So we can say we want to change positions 1 to 3. So this would be has a length of 2 to -2 and -3. So that's what we get here. So we have this ability. So the full syntax of slices is lower, upper, and then there's this optional step argument. So if we wanted to get an entire array, we'd say default lower, default upper, and default step, which would be start, stop, or start, stop plus 1 and 1. So that would give us the whole array. If we wanted just every other element, we could leave the start and stop empty, and then pass 2, which would change it from 1 to 2. So now we're getting 1, then skip. We go move up 2, -3, move up 2, and we get 5. And then it also supports this. This is also consistent with the overall syntax, but it also supports this notation we've seen before, where if we want the first 3 elements, this would be analogous from going to 0 to 3. Gives us the first 3 elements. And this would be analogous from going to 3 to the end, basically. So gives us starting from index 3 and then going to the end. And we can also do a -3 that should all be familiar from what we've seen already. Oh, yeah, sorry. I'm getting ahead of myself. So the negative indexes, again, also work. And so this slicing also works with multi-dimensional arrays. So here I'm going to create a 2-dimensional array using this list comprehension. So this is a more complicated version of what we've seen before, but it's just creating a list of lists, and then we're making an array of that. The point to make here is that we can do this 2-dimensional slicing. So we can slice and get rows 1 through 4, not including 4, and then columns 1 through 4, not including 4. So that'll give us just this inner section of the matrix. And it also supports strides, which are these like skipping a row, for example. So if we do : 2 for each, we'll get just the every other row and every other column. This could be useful if you wanted to just test something out on a subset of your data and you didn't want to run it on the whole thing. So we can also, we call this fancy indexing. Basically what we're doing is we're saving the indexes as a variable and then using that to index. So this, in this case, we're storing the indexes as a list here and then using that list to do the indexing. So we can do the same thing with rows and columns as well. And one thing you'll see a lot is using masks. This is kind of a special case of fancy indexing where instead of, I guess it's a little different. So with this fancy indexing or indexing, we're using the positions to get us to slice some of the data. With masks, we're using Boolean logic, which is just true false. So if for a given, imagine we have an array and it has 5 positions, and then we use a list of Boolean values that for each of those 5 positions says true or false. And if it's true, we'll get that value, and if it's false, it'll be left out. So this is a way to subset your data, and you can do this to get just the data that meet certain criteria, for example. So first we're going to create this array, and then we're going to make a mask. So this is a list of Boolean values. So true, false, false. And we're going to make an array from that. And then we're going to use that to mask or to subset this list B. So we take B, and then we just apply it as if we're using indexes, but instead of indexes, it's a mask. So this will give us just the positions where B was true. So this can be really useful. So here we're going to make an array from 0 to 9.5, incrementing by 0.5. And we want values, let's say we want values of x of this array that are at least 5 and have no decimal component. So this would be where x is greater than or equal to 5, and where x modulus 1, so this is what you get when you take x and divide, when you take a value and divide by 1, and the remainder, what is the remainder? So in this case we want a remainder that's 0 and not 0.5. So if we run this command, we get this array of Boolean values. So it's going to be false for the first half, and then once it hits 5, it'll be true. 5.5 is false, 6 true, etc. So then if we apply that that mask to x, now we can just get the values that we want. So it's a two-step process. First we get our array, and then we evaluate the array, and then we put those two things together and we get just the subset of the array that matches the criteria that we want. This is a really handy thing in a number of examples, because then with this array, then you can do things downstream with it.